All right, Dr. Tim, this recording's for you. It's my first one, so give me a little leeway there. uh, my presentation is entitled Why Are We Doing What We're Doing? The goal of the presentation is tell you what I learned about health and ultimately cancer, how I learned the information, how I learned the information wasn't the problem, it's sharing the information, and I want to share the information with you in the simplest way possible that I can present, and with hope of giving you realization, and then with that realization, maybe making this sharing, I don't know, just happen more often, and create an environment where we can get it to the people that need it. All right. Oh, one day I walked out of the gas station, Coke in my hand, and I looked down at my Coke, and I'm like, Ben, you need to quit drinking this Coke. It is not good for you. And then I'm like, hey, Ben, you don't know what good for you means. I'm like, yeah, I do. Well, I mean, bad for me. It's bad for me. Bad for me means sugar's bad for me. I'm like, yeah, sugar's bad for me. Wait a second, I still don't know what bad for me means. And I'm like, what am I doing here? I don't even know why I'm doing what I'm doing. It was kind of a moment for me, and I realized why is so important, and just a little picture of why is important. Little girl is in the kitchen. Her mom's making the Christmas ham, and the whole family's over. And she's like, "Mommy, why do you cut both ends of the Christmas ham when you put it in the pan?" And she's like, "Honey, you'll have to go ask your grandma. She taught me how to do that." Little girl walks in the next room. "Mommy, why do you cut both ends?" Or mommy, "Grandma, why do you cut both ends of the Christmas ham when you cook it?" She's like, "Sweetie, you're going to have to ask your great grandma because she's the one that taught me." And she walks over and, "Great grandma, how come you cut both ends of the Christmas ham when you make it?" "Well, honey, when I was making the Christmas ham, my pan was just too small, and I had to cut both ends just to get the ham in." Ah, you know, I'm gathering up all these information and all these ideas to pass on to my children, my kids, my son, my daughter. It would really piss me off if I was gathering up all this information for all the wrong reasons. So I started thinking about what am I passing on? Why is this bad for me? And this idea of knowing why and what was going on and what I was teaching my children started to drive me, and I started to study. I wanted to know how to be healthy and why. It led me down this road of understanding cancer and many other things, but cancer being the most pronounced. But it really wasn't about cancer. It was just about understanding how to be healthy and why I would be healthy. Little foreshadowing in this story, I'm studying along, and this road took me down studying metabolism. And I'm like going through all these different processes, very complicated and very deep, but I found this one process. See, there's two main processes of metabolism that you make energy, and we'll go over those in detail. Well, not in detail, but we will go over them often, just so we get a grasp of it. But there is anaerobic respiration and lactate fermentation. And I found this lactate fermentation, and it's only fueled by sugar. It's a 16th as efficient. And then the leftover sugar is recycled back into the liver. And then in this process, you create an acidic environment in the cell by creating lactic acid. I'm like, this is it. This is why sugar is bad for me. It must be. I still didn't grasp the effects of this, but I knew this was bad. Just describing it made me feel bad. So I filed that away, went on with my studies. And then it wasn't a week later I found it. This guy named Otto Warburg discovered back in the 30s that the difference between a healthy cell and a cancerous cell is lactate fermentation. The cell deciding to get rid of aerobic respiration and selecting lactate fermentation. And I'm like, this cannot be true. Oh, this cannot be the cure to cancer. And this guy discovered it in 1931. So I kept digging. I dug some more. I found another guy, Thomas C. Freud. This guy is a 30-year professor, 25 years at Yale University, 5 years at Boston College. He writes a book called Cancer, the Metabolic Disease. And he's producing mouse models showing this to be true. Basically, having tumors, get rid of the lactate fermentation, and the tumor is gone. And, at this point, I've got a pretty good grasp on metabolism, and I'm like, this is it. Dude, they have known the cure. Here is the cure to cancer. For me, I'm so excited to help people. And I know in my heart this information is true. And it's not just an emotional thing, because you know what? I am a very, what's the word I'm looking for? I'm a common sense guy. I mean, I've always wanted to be right. So when I was young, I wanted to be right. As soon as I said something, I just stuck to it so that I was right. But man, I got so sick and tired of being wrong sometimes that I learned to pay attention to which team seemed to be making the right sense and jumped on that team. So I guess I'm more of a bandwagon kind of guy. And so I'm so excited about my understanding, and I'm like, I gotta share it with somebody. And I've tried sharing with a few different people, and I'm an emotional guy. I'm a passionate guy. And it's a pretty deep subject, and I hit some roadblocks for sure. But it just so happened there was a guy in church, who's on the prayer list, and he had cancer, and he was in church one day. So I'm like, I'm going to approach this guy. I'm going to be calm. I'm going to engage in conversation, and I want to see if I can't help this guy. So I walk over, I sit down, and I'm like, hey, how's it going? How you doing? Made small talk. And but the conversation really amounted to this. I'm like, so have you done any research, or what have you learned about cancer? And he says, I think it's something in our food. You look at the increase of cancer in the past 30 years, and our food source has changed so much. It just seems to me it's got to be in the food. And like inside, I am just like, yes, I'm excited. He's going to get it. And then he follows it with this. He's like, you know what? I think there's a cure out there, but it's just such big business that I just don't think they want to share it with us. And I'm like, yes, yes, yes. He's going to get it. So with as calm as voice as I could, I broke into a slow conversation about metabolic process and what's going on, and how this lactate fermentation feeds sugar, and I'm just waiting for this light bulb to come across his face and be like, yes, you're right, and I'm going to change what I'm doing. I'm going to get cured from cancer. And yeah, the light bulb never went on. I shared a couple videos with him, sent him an email, and but I realized right there the problem's not the information, it's sharing it. You know how many things would have to change in his mind, or that he would have to know for that light bulb moment to happen? I studied on this stuff for 6 years before I had a light bulb moment, and had very good understanding of metabolism and many different things. So he would have to understand metabolism, understand the vocabulary very well. He would have to decide that he wants to take his advice from a construction worker as opposed to his doctor. He'd have to trust me. That just wasn't going to happen in that one little conversation. he would already, and he'd have to be completely non-dismissive. Say he got through all those things and was completely non-dismissive, and he took in all the information, and he would have to be strong enough to digest it on his own and then make a decision that may determine the outcome of his life. It just wasn't going to happen. And I knew I had to come up with a better message. So that's what I'm doing here today. So the next thing I'm going to do is I want to try to describe this metabolic process, just to give you an opportunity to kind of start to wrap your head around the concept of what's going on, and these people that are saying there is a cure to cancer, what they are saying, and go from there. So all the stuff I've watched and learned, everybody likes to use a little Albert Einstein and gain a little credibility. So I'm in deep need of credibility at the moment, so I'm going to use my Einstein quote here. It says, if you can't explain it simply, you don't understand it well enough. So my goal is to explain this as simply as possible. So the first thing we got is food. Our body uses food for fuel. All right. That food comes in 3 food groups, 3 types of food sources. We got protein and fat, which are essential for life. Essential means that you must consume them in order to maintain life. Now, the third group that food comes in is sugar or carbohydrates, and it's non-essential. This means you do not need it. Your body can synthesize sugar that it needs for life, so you do not have to consume it. It can synthesize that sugar from protein and fat. And if you don't believe me, these are the real 3 food groups. Look on the back of every label and you will find these 3 food groups. All right. So we take this food and we break it down into energy. All right. Little energy packets, I like to call them. These energy packets are adenosine triphosphate. All right. Just a complex word to say. I had to practice about 400 times just to say it, but it's just a small unit of energy. Ultimately, without these packets of energy, we have no life. We have no biological process. So now how we get these little packets of energy is this beauty right here. This is the mitochondria. They're in every cell in the body, and they produce the ATP. All right, works like this. We take in the protein, the fat, the sugar. We breathe in oxygen into the mitochondria. This is like your little generator. So we put in the fuel and we put in the oxygen, just like any other motor, and we crank out all this energy, this ATP. I like to akin it to just a regular generator that you might have to run your camper. All right, and all this takes place inside every cell. So you got your little cell membrane, your little nucleus here. A lot more things going on in the cell, but for simplicity, this is the way I did it. All right, so I bring in my food, add oxygen, run it through the mitochondria. I crank out the energy necessary for life. All right, now we have another process that we can go through, and it's called anaerobic respiration or lactate fermentation. Okay, in this process you only burn sugar, okay, and it's highly inefficient. You only produce 2 ATP for the same amount of sugar that would produce 30 ATP in aerobic respiration. All right, so it's highly inefficient at producing energy. And I like to akin this process to the generator. Like, say you had a can of fuel and you're going to pour it in your generator, pour it in your mitochondria, and that machine works really well with oxygen, and you crank out 32 ATP. But what if you didn't have this biogenerator right here? Then you'd be left with dumping your fuel basically out on the floor, and say you're in your camper and you'd have to dump a little in the bathroom to light it up, and then you'd have to dump a little in the bedroom to heat it up for sleep, and it'd just be really hard to control that energy, be highly inefficient, and basically that's what you have here. So without a generator and oxygen through aerobic respiration, without those things, then you have this highly inefficient process that burns lots of sugar, and it's called lactate fermentation, only produces 2 ATP. So, I mean, let's just get right to it. So, I'm saying, they say there's a cure for cancer, and it's real simple. Well, here's all they're saying. They're saying this process right here, this aerobic respiration, where we bring in food, add oxygen, run it through our biogenerator, and crank out a bunch of ATP, something gets messed up here. Either the mitochondria or the oxygen. One of these things is a problem. And so without this process, there's no energy produced here. So then we come down to anaerobic respiration, and it's a more simple system because there's only one process. Get sugar to the cell and it burns. And so there's less to go wrong. And in turn, this is the process that is used to feed cancerous cells. Well, what are they saying? Hey, if this process is broken, you can't produce this 32 ATP, then come down here and don't eat sugar. It's not essential for life. So if I don't eat this sugar, then I don't have this process either. Well, if this cell has no ATP from up here and no ATP from down here, there's no energy for biological process, there is no life. The cell dies. It's that simple. That's all they're saying. So let's talk about who's saying it, and let's talk about why they're saying it. So I got my boy Otto Warburg. All right. I want you to realize the people, there's just a couple people that I cover in here, but these are people with, I don't know, lifelong quests down the roads of these ideas that are saying these things. These aren't articles produced by maybe some big business, or an article produced by somebody that produces drugs, or somebody that had funding from this person or that person. These are monuments of science, people that are, their whole lives are rooted in these ideas and in this work of discovery. So take Otto Warburg here, for instance. 46 nominations for Nobel Prize. This guy was a Jew in Germany. I'm saying if he got credit, he deserved it. The guy hung out with the likes of Einstein, and he discovered that reduction of oxygen to the cell causes cancer. He wrote the book Cancer, Its Cause and Cure back in the 1930s. So what's he saying? Hey, I cut oxygen in vitro here out of the cell. This process wouldn't work anymore, and I got this lactate fermentation process. It's how the cell survived. And basically, those cells become cancerous. So the Warburg hypothesis is this. Warburg hypothesized that cancer growth is caused by tumor cells mainly generating adenosine triphosphate by anaerobic breakdown of glucose, then contrast to healthy cells which mainly generate energy from aerobic respiration. He says cells generally use aerobic and oxygen up here to generate energy, and that works great. But in a cancer cell, they switch to this process down here that's highly inefficient. Aerobic respiration, pyruvate is an end product of glycolysis and is oxidized within the mitochondria. Hence, according to Warburg, cancer should be interpreted as a mitochondrial dysfunction. Cancer, above all other disease, has countless secondary causes, but even for cancer, there is only one prime cause. Summarized in a few words, the prime cause of cancer is the replacement of respiration of oxygen in normal body cells with the fermentation of sugar. Okay, no respiration with oxygen up here, some kind of breakdown in the mitochondria, and we go to anaerobic respiration which is lactate fermentation, providing our energy. Very inefficient. All right, so now the concern is why the switch? Why do we go from anaerobic respiration to aerobic respiration? We know there's a switch, but why? And there's a few theories on that. Although the Warburg effect is a well-established phenomenon, we don't really understand why cancer cells switch to anaerobic metabolism. The Warburg effect is just that, the switch that takes place, going from aerobic respiration that's efficient to anaerobic respiration. One reason could very well be poverty of supply. Solid tumors, especially before they can recruit new blood vessels through angiogenesis, angiogenesis is the growth of new blood vessels, will often have zones with very low amounts of oxygen. Therefore, in this case, the use of anaerobic metabolism seems to be a simple consequence of lack of oxygen. They're saying just this: there is no oxygen available, so you can only do this to create energy for the cell. However, cancer cells will still use anaerobic metabolism even if oxygen is plentiful. So a lack of oxygen is not the only reason. The hypothesis that the mitochondria of cancer cell may somehow be damaged could be the explanation. Indeed, the mitochondria are important regulators of programmed cell death, adipoptosis. And cancer cells must inactivate adipoptosis in order to survive. Perhaps inactivation of adipoptosis somehow compromises the ability of the mitochondria to perform metabolism. They're saying that the cell is trying to survive and the mitochondria switches something off, maybe because there is no oxygen, but basically the cell is trying to survive, so it switches to lactate fermentation. All right. But this third one here is my favorite. Many of the intermediates produced during glycolysis serve as the starting points for the synthesis of vital cellular components, lipids, amino acids, nucleotides, etc. By shuttling material through glycolysis, cancer cells may be optimizing their capabilities to build more material at the expense of producing energy less efficiently. Dude, this says we're just eating too damn much. There's too much sugar going through the process of glycolysis. Now, in our society, we definitely don't have that problem, right? See, they're saying just to burn up sugar. We're just to get rid of all this stuff. We'll do this less efficient process just to burn the sugar up. See, it's like this. You go eat birthday cake, you don't pee it out, all right? Your body must deal with it. It's getting stored as fat. It's getting burned in the cell. Something's got to deal with it. So maybe burning it as 16th as efficient is a last-ditch effort for the cell to survive while it ODs on sugar. So this is what Otto Warburg said. I got a few more clips of information here of things that align with this idea. This comes from a renowned university over in Germany. I don't know these guys in depth, inside and out, and who they are and why they wrote this, but this is what they say. High glucose levels have been shown to accelerate cancer proliferation in vitro. Basically, when there is glucose available in vitro, cancer seems to run wild, while glucose deprivation leads to adipoptosis. When they take the glucose away and there's still other food present, the cell dies. These findings have initiated further study of the effects of carbohydrate restriction on tumor growth. Clinical evidence shows that lower blood glucose levels in late-stage cancer patients have been correlated with better outcomes, says German doctors Clement and Kamir, and I know I just butchered his name. So they're saying the same thing. Cancer is feeding on sugar. and you take the sugar away and the cell dies. So in oncology, that's the Warburg effect is the observation that most cancer cells predominantly produce energy by high rates of glycolysis followed by lactic acid fermentation in the cristae, rather than comparatively low rate of glycolysis followed by the oxidation of pyruvate in the mitochondria, as in most normal cells. Basically the same thing I've been saying over and over. They're switching from this process to this process. The latter process, aerobic oxygen. Malignant, rapidly growing tumor cells typically have glycolic rates up to 200 times higher than those of normal tissues of origin. They're saying cancer cells are burning sugar up to 200 times as much as a regular cell. And when you look at this process, this is so inefficient. You're going to have to burn more sugar in order to just keep up the energy needed for the cell. So everybody's throwing sugar under the bus. Sugar's the root problem. Cancer feeds, we've all heard cancer feeds on sugar. And here they're saying it. They've been saying it since the 1930s. You know, I'm accepting these metabolic processes as textbook, which they are. Okay, I have the two processes here. All right, I have anaerobic respiration and anaerobic respiration. Or excuse me, I have aerobic respiration and anaerobic respiration, which is lactate fermentation. This is textbook stuff. This is no new discovery. This isn't things they're still trying to figure out. We know this to be true. All right, so I accept that as truth. I'm okay with doing that without doing the lab study myself to see it happen. I accept that as truth. But for them to say cancer's feeding on sugar, I mean, I just kind of, without a lab, without some kind of, I got to take their word for it. I just got to believe that cancer's feeding on sugar. And I just kind of have a little hard time with that. Just common sense. You tell me it's so, but how do I know? And then... Oh, I can't believe this. When I found this, I'm like, this just cannot be true. But it's called the PET scan, positron emission tomography scan. Okay, PET scan. They inject you with fluorodeoxyglucose, an analog of glucose, an imitation of glucose. All right. So you go to the doc. He takes a syringe, injects you with sugar, right? And then they run you through this scan, and the scan will pick up radioactive material. Well, this sugar that they injected you with is radioactive. So wherever that sugar is in your body, it's going to show up on the scan. Anybody want to guess where the sugar is in this scan? You know, at this time, his body's taking up sugar everywhere. But some places are possibly taking it up at 200 times the rate of others. And so they found his kidney cancer by injecting him with sugar. I'm like, oh, no shit. Cancer is feeding on sugar. And I'm like, dude, this story is making too much sense. It's too simple. They must be able only to use this for like finding one kind of cancer. So I looked a little more. And I started finding pictures of all different kinds of cancers from PET scans. And I'm just like, I mean, this is so obvious and true. I don't know. This is where, like, hey, am I crazy? Am I making this up? Am I missing something outside of this? Then I found this. If the biological active molecule chosen for PET scan is fluorodeoxyglucose, an analog of glucose, concentrations of the tracer imaged will indicate the tissue's metabolic activity as it corresponds to regional glucose uptake. They're straight up saying, this is the producer of the scan that put out this information that will inject you with glucose and watch for glucose uptake. Use of this tracer to explore the possibility of cancer metastasis. Oh man, I just butchered that word. Still can't get it. It is the most common type of PET scan in standard medical care. 90% of current scans, they are injecting people with glucose to find their cancer. They are using this scan 90% of the time. This is the most widely used scan by far to find cancer. Anybody want to guess where this person right here is burning sugar at? Right there. So what's it say? Boom. Don't eat sugar. So your body, you have, there's always some level of sugar in your blood, all right? Because your body can synthesize that sugar from protein and fat. But it's nothing like the levels of sugar you have in the body when you start consuming cakes and breads and all these inflammatory foods. And there's another guy, the other guy I mentioned, Thomas C. Freud, all right? And I just took the preface from his book and just wanted to run through it quick. This guy is on the cutting edge today. I don't even, it's almost hard to call it cutting edge. It's just, he's got to nail it down so well, because it seems to me, I don't know this, that the mainstream just denies it because they've looked at it such a certain way for such a long time. And then when you've looked at it at such a certain way and it's how you make your living, it's hard to turn away from your living and how you look at something, both. You know, it just takes so much more energy. But this is what he says. Cancer persists as a plague in modern society. Well, you're right about that one. Lack of progress in either managing or preventing cancer motivated me to write this treatise. I am a biological geneticist, and I have worked on lipid biochemistry of cancer since the early 80s. Do we get this? This guy has got 35 years in this tiny little spot or subject. Not yesterday, not 2 months, not 2 weeks. And now he's laying his whole career on the line by putting out this book and claiming that it's a metabolic disease. All right? This guy's for real. I have developed numerous mouse models for brain tumors and systemic and metastatic cancer. Several major findings planted the seeds for this treatise. All right? First, it became clear to me that therapeutic action of some anti-cancer drugs operated largely through reduction of caloric intake. When you stop eating sugar, you stop feeding cancer. Second, reduced caloric intake could target the majority of cancer hallmarks. Third, that the ketone bodies, fat, when we eat fat, our liver creates these things called ketone bodies. See, we have this whole biological process. We actually have this whole system called the lymph system to manage fat. And then we have a process where the liver takes the fat and turns it into fuel. And you know what? Almost nobody uses that process in their body as a source of fuel because we eat so much sugar. A buddy of mine who's on the same diet, he goes in for a physical at work and he pees on the strip. And on the strip, it'll tell you if you're burning fat or burning these ketones or not. And the doctor got or it wasn't a doctor, it was the nurse, got a reading that there was ketones in his blood. And the guy like, I gotta go get the doctor. I'll be right back. He didn't know what to do. Doctor comes in and says, "You eating you're on a fat diet, huh?" He's like, "Yep." He's like, "Oh, okay. Everything's fine then." This nurse sees hundreds of patients, and We have this whole way of reading. We have a lymph system. We have this whole fuel process, and people don't even use it. We're just burning sugar, and it's not the best way to live. But here's what he's saying. These ketones, this fat, can serve as an alternative fuel to glucose in most cells with normal respiration function. Fourth, metastatic cancer arises from... No, I don't want to even cover that. We'll just... Fifth, that all cancer cells, regardless of tissue origin, express a general defect in mitochondrial energy metabolism. He's saying what we've been saying the whole time, and that is all cancer cells have a dysfunction with the biogenerator. All right, the biogenerator is not working for some reason. We resort to lactate fermentation or breaking down of sugar without oxygen. That happens in all cancer cells. Here's one of his mouse models. Standard diet, and then they restrict calories, all right, and they get reduction in the tumor. Now, a ketogenic diet or a fat diet, they have the tumor, and they restrict calories in the ketogenic diet or the fat diet, and there's even more reduction in the tumor. I mean, yeah, it's not a human, but the deal is, man, it's laid out in a mouse model. And you know what? There's lots of stories. If you're willing to look and listen, there's many more stories of people getting themselves healthy. Actually, Doc, you've got one yourself. Your friend said, hey, I cured my cancer on my diet. And dude, there's a lot of people that know about it. It's not just me. This Hoxie guy, I watched a few videos on him. I mean, he fought with the government, and he was a fighter. I do know that there are several threats on his life and so on and so forth. Cured thousands of people. Here's the guy, C. Freud, I was just talking about. He wrote the book, Cancer, the Metabolic Disease. So Max Garrison, actually, he's got an organization that's still around today. I think his daughter runs it, and they're helping lots of people get better from cancer. It's just not mainstream. And why is it not mainstream? What if I told you there are multiple cures for cancer, but they are suppressed because cancer is a $160 billion a year business? We got to think about how many people we would have to communicate this message to, and how many people would be able to wrap their mind around it at once for there to be a change. I mean, Doc, I try to tell you, and in some sense of a way, you basically laughed me out of the room. You're like, well, when the person that does discover cancer is going to have to guard himself because, people aren't going to believe him. And it's true. So, if you got a statement that's hard to believe because of the way we've been so inundated that there is no cure for cancer, and then the people that would physically make the change on the ground, you're basically going to take away their livelihood, their money, and their jobs. That's what we're up against. And I honestly believe that's why the change hasn't happened. The change has got to get grassroots. We've got to start sharing this information. I didn't create this info. I just discovered it. And yeah. And I'm not afraid to talk about it. And that's the thing. We got to get to where we can talk about it. Even if there's a chance I'm wrong in this situation, which maybe there is. But show me I'm wrong with logic, a logical explanation that makes sense, that says, hey, this isn't right, and this is why. And you know what? I would drop this information like a hot potato, because you know what? I'm the guy that wants to be on the side that's getting the answer right. That's who I am. I don't have to invent. I left that idea a long time ago. I don't have to invent the right answer. I just want to be on the winning team. That's how bad I want to be right. So I drop these guys like hot potatoes. But man, I see the winning. You look at our cancer industry, our cancer care today. People are not, man, they're going through horrible, horrible experiences. It's just not getting better. So let's be rational. That means you would have to consider this information. Consider it completely and then make a choice. And then let's not be afraid to talk about it. And man, if we're not afraid to talk about it, we might create an environment where that buddy of yours, his little girl is dying of leukemia. Maybe we could change her life and change his life. So Doc, I appreciate you for taking the time to listen to this, man. And that's what I have. I want to make a difference. And everybody wants to make a difference. Sometimes we're just afraid. And I'm sick of fucking tired of being afraid. I'm so sick of being afraid. Thanks, Doc.